Hello and Merry Christmas. It is time to talk about measurement and our pre-lab. When we start labs, what you're going to do is you're going to have your page in your lab notebook. You'll put the title on there, Measurement Lab. You don't have to write college chemistry. And then you're going to write the beginning question. The beginning question is the question we're going to try to answer. The beginning question for this lab is going to be, what lab equipment can you use to measure accurately? So this lab we will be using some measurement techniques that we discussed, and being able to read our measurements to precise levels so that they are significant. Alright, starting part A. So after you've written your beginning question, and keep in mind if you're watching this at home, you can pause it whenever you need to. I'm sure I will have paused it by now when I show you this in class tomorrow. Part A says, examine each graduated cylinder at the station and fill in the diagram. So there's going to be 3 different graduated cylinders at your station. And you're going to tell me about those. Okay. The type of questions that it's asking. Oh, this is formatted so well. It wants to know, cylinder A, what's the maximum capacity? In other words, how much can it hold? What's the major scale? That would be the the numbers that are on the graduated cylinder. The minor scale, which are the simple markings, and then the volume that you're reading, including to your most precise point. So you're going to have to estimate that last digit. The second thing, for part B, you're going to take a 250 milliliter beaker. Now what I want you to do is draw this along with me. I know it sounds crazy, but this works. So we have our 250 milliliter beaker, and we are going to measure out 100 milliliters of water. So from the sink, you are going to pour in 100 milliliters of water using the measurements on the side of the graduated cylinder. After you've done that, you will then, and this is step 2, this was step 1, step 3, you'll pour that beaker into the graduated cylinder. And see what the measurement is in there. So you're going to see, is your 100 milliliters really 100 milliliters? Question 4 says, which is more precise? Okay, think about it. You had 100 milliliters here. Did you hit 100 milliliters here? Was it a little above, a little below? Which is going to give you a better, more accurate measurement? Alright, so you'll have to answer that question. I don't know where you'll answer it, but you can just write it in your lab notebook. 5, you're going to calculate percent error. To do percent error, we're going to take the 100 milliliters that we said that our 250 got, and we're going to subtract that from the theoretical. The theoretical amount, or the 100 milliliters is the theoretical amount. That's what we were trying to get. The cylinder is what we actually got. So we subtract those and we take absolute value. Then we're going to divide by the volume that we found in the cylinder and multiply by 100. And that will give us a percent error. The closer you are to 0, the better the error. Alright, so then we'll do step 6. We'll do the same thing. We're going to get a 50 milliliter beaker and measure out 25 milliliters from the sink. And then we will pour that 25 milliliters into a graduated cylinder and see what the reading is there. And then we will calculate. We'll take the 25 milliliters minus what's in the cylinder, divided by cylinder. So you can figure out which is more precise. All right, for part C, we are going to use a metric ruler, and we're going to measure the diameter of a penny. So you're going to have a ruler at each lab station, and you're going to measure the diameter of the penny. Step 8 asks you to put in, or to stack up your pennies till you get a stack. And because I can't draw a stack of pennies, I thought it would be better to find a picture of a stack of pennies, but I didn't think that out very well. And that is a really tall stack of pennies. So you're going to make a stack of pennies that is approximately 10 millimeters high. Okay, if it's a little above or below, that's okay. Step 9, you're going to measure the precise height. So you're going to take that stack of pennies and you're going to get your ruler out and you're going to measure the height and record. Step 10, you're going to measure the thickness of one penny in millimeters. And then calculate the percent error by taking the average number that you calculated. You calculated the average number by, back in step 9, after you measure that, you're going to divide by the number of pennies. I left that out. Step 10, you'll measure the width, and then step 11, well, it doesn't say step 11, you're going to take the average minus, so the average is number 9, minus the measured height, which is number 10, divided by number 10, times 100. And then it asks you to repeat with a nickel. I'm not going to draw the steps out again. Finally, part D, you're going to get 5 pennies. You're going to record the year they were minted. So here's Abe Lincoln. It looks like Abe, doesn't it? And on there is going to be a year. You're going to record the year they're minted, and then you're going to mass each penny. Alright, so this is what I use for a balance. Our balances have round pans and they have square fronts. So this is how I represent a balance. I put whatever it is we're going to be weighing on a balance picture, and just like this. So you're going to mass all 5 pennies and record them. And then you will take the average, or you find the average mass, and again, you'll take the average. Well, we can't really do percent composition for this one, so never mind. So find the average mass of 5. We could do it for just one single penny, but I think you're going to find the reason we want you to write down the years is makes a difference when they were minted. All right, that's all for today. Thank you very much. I'm going to figure out how to turn it off.